We've set a challenge for 2 maths teachers from Framwell Gate School in Durham. They're being summoned to a mystery location. Right now, neither teacher knows their destination or the topic they'll be teaching. Their lesson needs to be ready by 2 p.m. this afternoon.
It's the unknown, isn't it?
It's the unknown side of things. It's exciting, yeah, it's a wee bit scary.
Yeah.
They're on their way to the Baltic Art Centre in Newcastle, and they're about to meet contemporary artist James Johnson Perkins.
And really, I just want to get them to be as inspired as they can to make things. How can they do it? And make things that are bigger than themselves as well. This is nice, isn't it?
The challenge for the teachers is to create a cross-curricular maths lesson using applied art.
What I would like you to do...
Dr. Elaine Fisher is assistant head teacher at Framwell Gate, and she's been teaching maths for 8 years.
You kind of get used to the setup of your classroom and how things will work. So the idea that we're going to be doing it in a totally different environment will be really interesting to see the effect that it has on the type of thinking that we do in terms of our planning, but also the way the students respond as well.
Her colleague, NQT Rosalind Taylor, has a background in engineering and has been teaching maths for a year.
The creative side is probably where my strengths lie, sort of thinking up different ideas, and Elaine's quite good at sort of keeping me down and then saying, okay, let's see how we can actually put that into a lesson.
Awaiting them on the roof of the Baltic is a box of 3 specially chosen resources. These are the vital components of their lesson.
Ready? Random weights.
And some rules about bridges.
It's 8:30 a.m. and our 2 maths teachers are speeding their way out of their comfort zone.
I hope it's algebra.
Yeah.
Or number.
Algebra's nice because you can link it
Yeah.
to so much different stuff.
The quayside surroundings of the Baltic and the box of resources should provide them with enough inspiration for their lesson. Let's hope so, because by 2 p.m. this afternoon, they'll need to be ready to teach a class of Year 8 pupils.
I think a lot of people don't really like maths. I just can't do it. Not very good at it.
Certain things I don't really like about maths, just...
Like, I don't understand some things, but then it's a challenge, so you can work on it.
In maths, you just need like a practical side to work stuff out.
I don't like the idea of doing shape stuff.
Shape stuff's harder.
I think that's
It's more constrained, I think.
Yeah.
Are we close?
Right.
I have no idea.
That's the trouble.
I don't even know where anywhere is around
You
here.
don't know Newcastle though, do
I
you?
don't know Newcastle
Whereas
at
at
all.
least I know Newcastle a bit well.
Right, where are we going then? You're local.
No.
Which one?
It's the Baltic.
Huh?
That's the Baltic way.
Where?
I think that big building coming up there.
What building?
This one on our left. Wow.
What's the Baltic?
Have you been? It's a contemporary art gallery.
An
But
art
it's like
gallery?
really modern. It's got an amazing view out down that way, so you can see all the bridges and right down the Tyne.
I want something we know something about.
Well, that's the way I don't know anything about art. Art's not one of my strengths.
I can paint, but I don't know anything about art. Oh dear.
Lovely view.
Yeah, the bridges are really cool. I really like the Millennium Bridge in particular.
Hello, I'm James Johnson Perkins and I'm a
Nice to meet you.
freelance artist
hiya.
here at the Baltic Gallery.
Nice to
Nice to
meet
meet
you.
you.
If you look here, we've got a box, and here's the key. And inside the box, there's objects that you can use to inspire you for this lesson that you're going to be doing. So open the box.
You can open the box. Excellent. Ready? Ooh. Ooh.
Sequences and bridge signs.
Oh,
See what else there is.
thank you. There's coal. Coal? That's really random.
Well, they use it to take over the bridges, don't they? And some
What?
weights.
It's a bucket itself.
Wow.
Okay.
There's something else. Oh, look, there is. Oh, it's a...
Watch me.
It's like Alice in Wonderland.
Yes.
Excellent.
Well, the bridges is good. sequences, patterns, different bridges. We've got bridges here, although I find the coal really random. I don't know what you think.
Yeah, I think it's the cool. The others, well, even the weights to a certain extent. This I can see in the surroundings.
I mean, there's lovely algebra is what we wanted, right? We love algebra.
Yeah, so that's
and the
good.
pattern and sequences, the bridges, the weights. I can see a link there.
Weights and bridges.
Yeah, I can see links there.
Strength. Definitely.
Oh yeah. I'm feeling a lot more comfortable now that I
like knowing.
Now I know what it is. Like
Yeah.
my brain, I feel like my brain's already working.
Need to find out if this is going to tell us what our actual topic is.
Yeah, but I'm pleased so far.
Right, so we're going to watch the DVD and then we've got a couple more surprises for you downstairs.
More surprise. Okay.
Started.
Okay.
The objects in the box have been specially chosen by 2 experts. First up, Adam Goldwater from the Discovery Museum in Newcastle. He has some tips on how they might use the coal and weighing scales in their lesson.
The objects that I've chosen for the students to use are a bucket of coal and some scales. Coal, black gold, is really the foundation of the prosperity of Tyneside, the Tyne, Newcastle, Gateshead and the region. The challenge of getting coal quickly and efficiently from the coal face to export from the River Tyne is really seen all around us in the bridge designs, the railways, the staiths that we use to load the coal onto the ships. So the maths could be brought in to examine the real-life context of the bridge designs that were subsequently built to allow the greater ships through.
That would be nice, wouldn't it, to have something that has a cross-curricular link with the kind of history as well.
Yeah, because that's something, that you know.
My background.
Exactly.
You got your engineer.
Engineer and the history.
What more do we need?
Yeah.
Artist.
And the artist, of course.
Right.
The second object we have here is a set of scales and measures. The teachers could use these as an activity to measure out how much coal could possibly be loaded onto, first of all, the small keel boats and then larger and larger ships. Bearing in mind that coal itself doesn't come in a uniform shape or size, putting it into real-life context and a context that would have had to have been considered in the past.
I was quite surprised by the coal, but then obviously, like, when me and Elaine started talking afterwards, like, yeah, obviously linking to the sort of the mining history, I thought, yeah, it makes sense.
I mean, for me, my background's in history and maths, so the kind of links between that, I really like the opportunity to kind of link the 2 subjects together.
The equation B equals 2j minus 3, showing the relationship between joints and beams, has been placed in the box by Steve Humble from the National Centre for Excellence in the Teaching of Mathematics. He's also got some tips on how they could use the space around the Baltic in a lesson.
An interesting thing from a mathematical point of view is that this space, the river is the same width across, but different engineers have used different techniques to span that space. So I think it would be quite interesting to get the students to try and look at the different curves across the river and see whether those are the same shape curves for the different bridges.
Yeah, because scale factors.
Scale, proportion,
It's kind
all
of,
that kind of stuff.
That's going to be kind
Angles.
of ratio.
Yeah.
Angles, yeah.
So using this formula would be a good place to start, because what it'll do is it'll give the students an idea of how many joints and beams they need to construct their bridges if they build them with this type of construction.
In some ways that was much more the comfort zone, because you get the board with mathematical information, a sequence, you think, oh, I can do that because that's maths, that I'm happy with that.
At that point, you've got everything open to you. You've got safe routes, you've got more adventurous routes, you've got totally wacky routes, and it's kind of up to you to kind of say, right, well, I'm going to take it and go down this sort of angle or whatever.
James has one more surprise left for them. He's giving them a much bigger classroom than they're used to.
So, this is the space that you're going to be working in.
Wow.
That's quite, quite big.
Impressive space.
It's very blank.
You've got very simple materials to work with. You'll be thinking about things like structure, maybe things like that to build a curve. I sort of have quite a good knowledge of maths. Really, I'm a maker, I make things. I'm interested in the process of putting things together and And really, I just want to get them to be as inspired as they can to make things. You know, how can they do it? You know, and make things that are bigger than themselves as well. This is nice, isn't it? Something like that. I've actually taught maths in school, so I've got quite a sort of maths brain. In fact, I won the maths prize when I was at school. But how you do that and how you use these materials to work out a mathematical maths lesson is up to you. But we would like you to use all of the space. So whatever you're making, it's going to fill the space.
Wow. I think it's great, isn't it?
I think it's, yeah, I like the idea of having loads of space spread about and kind of, especially with it being like quite practical based.
Yeah, definitely. I love the view. I think the idea of teaching in a space like this where you've got the view out there to kind of keep them inspired with the kind of topic and the bridges is fantastic.
And linking that into what they're actually doing and hopefully seeing the whole real life context thing is really good.
Now they've got all the ingredients, and with their Year 8 pupils arriving shortly, it's time to start planning.
Right, okay, so I can appreciate and enjoy art. I've never particularly had a great strength in doing anything terribly artistic, and I think that you kind of, outside your comfort zone, you perhaps panic a little bit.
It was all really appealing to me. The whole idea of filling that space was a challenge. It was like, okay, we've got all this massive space. And I mean, yeah, it's a little bit daunting because it's a massive room. And you think, okay, you know, we've only got an hour for a lesson, we've got to fill the space in an hour. Yes, that's quite scary. Let's do a bit of a sort of brainstorm thing first of all.
Let's put bridges in the middle, shall we?
Yeah,
we've got the cool.
We've got the cool.
Scales. We've got outcomes, haven't we? Outcome is they need to build a structure.
There needs to be a structure built.
See, it's this idea about, I'd like to get this into it more. Well, what about if we start with something looking at the bridge designs? So we're talking about the different bridges that are out here, because if you think about the bridges we've got out here, we could get them to think about, we talked about history, didn't we? Perhaps asking the question, what questions?
Inquiry-based learning, then there's questioning.
So, our problem is going to be that we've got the space to fill.
We've got the space to fill, yes. Could we give each of them a time era, and they've got to build a bridge according to that time era? But you could make it that they've still got to have a certain object of a certain height, like someone like a person walking or someone's got to walk underneath each bridge and to represent the ships.
And they have to be able to justify why they've chosen the design they've happened and what are the strengths and
weaknesses.
So the end bit is that they present the bridge with the rationale for why it's good. So they've got to get the aesthetics, they've got to get the maths.
I've got a bit of maths, right? We've got the river, see that represents your river, and say, right, okay, that's the distance of the river. And then say, well, you've got to work out what, we say the ship is 25 metres, whatever, right? They've got to work out what that would represent on their scaled model. Something must be able to travel under your bridge. An object of height X must be able to travel under your bridge.
Okay.
Because that links to the whole transport of the coal.
I wonder if we could find an object out there we could borrow that's like one of the kids' toys.
That looks like a ship. Yeah, right, okay. We'll find something that looks a bit like a ship. So then we say the ship is 25 metres high, they have to work out actually what height that would be in the scale model to represent what they have to kind of go over, do you know what I mean? So
we're getting scale.
So we're getting scale and proportion into there.
I like that idea.
Because that's definite math content.
Hello?
Hi.
How are you getting on with your planning?
I think we're just about there, aren't we?
Pretty much.
Okay, so we're going to say to them, this is the success criteria that they've got to meet, which involves them building a bridge and doing a little presentation describing why they've done what they've done.
Okay.
And while they're doing that, the information they'll have available to them is they'll have the board that we were given, they'll have you as the art expert,
okay.
They'll have us as maths experts to ask.
Sounds really good.
Go and get ourselves.
Yep, let's go.
Elaine and Rosalind have decided on an inquiry-based lesson. They'll be challenging their Year 8 pupils to use mathematics combined with applied art to design and build scale model bridges that will fill the gallery space.
What do you think we'll think of it?
I don't know. Should enjoy it. I mean, hopefully she'll be quite interested.
I hope so. But I think once we hit on the idea that we wanted it to be an inquiry-based lesson, that was the kind of key point in terms of moving our thinking forward, because we were able to realise that if we were going to base it around that structure, we could use the stimulus we had from the various objects and build that into getting the students engaged in the kind of big challenge activity. Okay, can we start by getting ourselves in a circle around the bucket in the middle, please?
Basically, we're here next to the Baltic, okay, which is a contemporary art museum, and we're sitting just on the edge of the Tyne, okay? Looking around you, what I want you initially to think about is what sort of maths can you see around you, okay, with a particular reference on the bridges, okay, so thinking maybe about shape, things like that. maybe looking a bit with history as well, okay? Just quickly jot down your whiteboards, talk among yourselves, quickly jot down anything you can think of that you can see that's linking to maths around you.
The bridge side with the tension.
Oh, the tension, good word.
It's got to be strong enough to hold like so much weight.
Okay, what we're going to do now, guys, is I want you to look at what we've got in the centre here. We've got a bucket of coal, okay, which might seem a little bit random. My challenge to you is how does that link to our surroundings? Okay, so thinking about how the coal links.
When they're taking us along the rivers, you've got the bridges, and we need to think of ways we can get the coal underneath the bridges.
Yeah,
like
so starting to think about the bridges and looking at the bridges around us and the height of the ships and things, yeah? That's a really nice thought, and that's a thought I want us to take on when we go upstairs now, okay? So, let's move upstairs.
And they came up with some really obscure ideas that we wouldn't have thought of that were fantastic, and instantly kind of getting to much higher level topics than we would have thought of in terms of the tension and strength and so on of bridges, and something that showed they'd really kind of thought around the objects rather than just writing objects down and saying what they were.
Now it's time for the students to meet James and start designing and building. They've got the coal, but decided not to use the weighing scales.
I mean, it could have opened up really into quite a big sort of two-week project, easily looking at the weights and things like that. So the scales themselves, we kind of left them there to use, and the kids could use them if they wanted, but they never really sort of involved, because I don't think we could use everything. That was the thing, because we had so much.
You can see that we're in this amazing space here in the Baltic Art Gallery, and what we're going to do is we're going to set you a challenge. So your challenge is to design and construct a bridge in the style which will be given to your group, taking inspiration from your surroundings and the bridges around you. Your bridge must be able to cross the River Tyne. What are all the questions that you need to be asking in order to help you to solve that problem?
You need to know what's going under it as well.
How wide the river is, because there's no point having the bridge too short.
Yeah, and they generated some great questions to do with the strength, the weight, the width, the questions they needed to ask about how wide the Tyne was, about what it might have to support, what kind of traffic was going to go over it, and some really interesting ideas.
Like the swing bridge and the green one, they don't have supports, but them are the ones that have the semicircle over the top, so maybe that supports them a bit.
What do you think? See how the bridges, I mean, they all look different, don't they? What do you think, what things affect how a bridge looks? I think initially we were both thinking, yeah, we need to go down some sort of algebra route, because that was where we both felt most comfortable. But actually we never really went down an algebra route at all. We went down much more of an applied maths route, which actually turned out sort of really well, and it was a geometry route, which I don't think either of us would initially have said we were going down a geometry route, but it was just, I think almost we were inspired by the environment as well as the kids.
You need to construct a bridge which will allow a boat, this is our boat, which is carrying our coal up and down the river, and this has got to be able to fit underneath your bridge. A nominee from your group must also present for 2 minutes at the end of the building session to tell us exactly why you've chosen the design you've chosen, what the maths is behind it, and why you would persuade an investor to invest in your bridge design. So I'd like to introduce James Johnson Perkins, who is a freelance artist who works as a consultant at the Baltic and who is here able to give you consultancy advice on your bridge design.
So any questions about kind of how to make it what size, how do you make it the structure of it, how do you make it strong? These are the materials that you're using. So you've got boxes and you've got tubes. So you think about how you're going to put those tubes together, how you're going to make your structure, how big is it going to be, how's this going to fit underneath.
Okay.
And you take your inspiration from whatever you see out there and from whatever's in your imagination, okay? Got it? Okay, that's your task, guys.
I think we need about 7 carbon. 23 centimetres, like each floorboard.
That's 1.2. someone to there.
Yeah. So what do you think you need to make it a little bit stronger when you look at all these other bridges?
Like maybe
You need to look at yours and say what you think is going to make it stronger.
no one said we can't take the cardboard boxes to pieces.
When you're like actually building things, you have to build in 3D, so it's a lot harder than you think, because you have to think about the shape and the volume and area of it.
What I would take from it is the confidence of just letting them go. It's shown me as well how valuable it is, and how you can see how much enjoyment the kids get about it. They were all engaged, they were all on task, and there was hardly, I don't think there was anybody who was sitting doing nothing. They were all right in there, and the interaction between each other, the social skills they were developing, as well as their math skills, was fantastic to see.
How can we use that on a box to create something that's going like that?
And I thought a lot more maths came out than we'd thought of. I mean, we certainly hadn't thought of the idea of the angles of the bridge that James was using to work out his angles so that he had the right number of boxes to make the arch work. And I think, you know, it shows a lot of kind of higher level thinking in terms of their approach.
Well, we're supposed to be building an arch, so we're using the tubes to prop up the boxes to make it lean over so it makes an arch shape. And it'll be quite high as well, so I think they're coming through.
Lovely. Working in a classroom, you don't come across problems that you come across with real life. In a classroom, you just write it down and you don't need to prove it, but here you've actually got to have proof, like the width. If you can't make it wide enough, you've got to try and adjust it, and that was quite a big problem we had.
It's going under it, it's all right, I think. So,
part of our concern was them having enough time to actually build the structure, and I think we were a little concerned when we were planning that they might not have an actual finished bridge.
We're not sure if we've got enough cylinders to make the triangles to make it strong enough.
We need another tube on one end attaching two of the pillars so they'll actually fit across the river, the bridge, otherwise we're stuck.
It was brilliant to see that they all had a finished structure, and they could all explain merits about it, which was nice.
Go on the dryer, you can do as well. Superb.
Excellent. Okay, James, do you want to share your presentation with us?
The curve is created by when you put a cylinder between two boxes, it elevates it, and each one of these is about 15 degrees. So it's about 6 to make 90 degrees.
I think if we'd have made the angle a bit smaller, we could have had it a bit more like a circle, couldn't we? Because we decided on that. But I think it's a really, really good effort. Yeah, brilliant. You should be really pleased and proud of yourself. Give yourselves a pat on the back.
Excellent. Okay, the team over here who were the truss bridge.
Well, if you put triangles like a line across the top and maybe down the middle, that gives it a lot of strength.
I'm really loving this, the shapes that you've made and the triangles, and it's pretty similar to the bridge down there as well. It's pretty similar. I described this one as brilliant, and I described this one as awesome.
Excellent. All right, thank you. Shall we have a look at the final bridge at the bottom then?
Yeah, looks interesting. Is it wide enough?
It looks like it's just about
Oh,
right.
it's just going to go under. Superb.
So what we've done is, first of all, we've taken the fact that the boat needs to get under. And if you were really going to build this, we've taken the idea that each box would represent a height of 5 metres and 2 metres across. So in total you'd have the bridge about 35 metres high and about 32 metres wide. Then down here, just for an extra bit, we've just added legs sticking out the side for a bit more interest and further stability.
We talked in our planning about looking at the actual sort of scaling up to the river, which one group did without us even saying anything to them. They're like that, oh, well, this is actually a scale, and the river would actually be this big, and they'd estimated the size of the river and things like that. So it was almost like, yeah, giving a group of students like that, the freedom that we gave them, really let them sort of take off in their learning, and they could kind of explore however they wanted, and different groups were exploring different things and getting different things out of it, which was fab.
I really like the fact that you've used different shapes and different kind of, it looks very sort of sci-fi and a bit very modern looking. And what I really love the difference between the different shapes, all the 3 different bridges. Like you've really all thought about how, you know, what shapes you're going to use, what the structure is, all that kind of thing. That one at the end is awesome, and I think this one has to be described as amazing. So, all in all, I think a really good effort. Well done. Thanks for all your hard work.
If you've been inspired to try out teaching outside the box, how about contacting your local art galleries and museums? They can often set up tailored challenges to suit your class, or even loan you themed boxes of original artefacts and images to use in a lesson. You can find some useful web links on the page associated with this programme at www.teachers.tv.
Now the last thing that we want you to do is we want you to, in your groups, evaluate each other's bridge.
The more abstract links, like linking with art, actually it's really motivating for both us and the students to think differently, and it would be great to do more of that kind of thing in the classroom.
It's much better being able to work things out by yourself than having to take your teacher's word for what. Like if this is what a circle is, then actually being able to work out what it is by yourself and what will work and having to try it.
It's like really good. It's like you're better off because you're in more space and you get to work and move around and do what you want really with what you're doing. It's your own ideas.
I think it gives me confidence in that style of teaching mathematics, and just really encourages me that actually, yeah, that is a really good route to go down, away from the traditional classroom board teaching. This is something I'm trying to get away from anyway, albeit we can't always take them to the Baltic and to the bridges, but you know, even just getting pictures of real life things and saying, like, let's take inspiration from this, how can we then sort of apply math skills to that is something definitely that I'm going to take forward.